ME 8492 Kinematics of Machinery Unit 4 Gears and Gear Trains Tutorial Problem 2. Here in this video you will see the problem about the interference in involute gears presented by TPGIT. Well, but let's see interference in involute gear. What is interference in involute gear? Okay, this is the two gears, gear and pinion. Gear and pinions are mating. This is the pinion, this is the gear. Okay, this is the outermost circle is the maximum addendum circle. This is addendum circle of pinion. This is pitch circle of the pinion. This is the base circle of the pinion. Similarly, this is the gear wheel. This is the base circle of the pinion. This is the pitch circle of the pinion. This is the addendum circle of the pinion, and this is the maximum addendum circle of pinion and gear. Okay. Uh, Here, this is O is the center point of O1 is the center point of pinion and O2 is the center point of gear wheel. M1 is the common tangent on the base circle. Okay, MN. The MN is the common tangent on the base circle. This is drawn from the base circle, common tangent on the base circle of gear and pinion. Okay, and KL is the path of contact between the two mating gears. This KL is the length of path of contact between the gears. The KL is drawn from pitch circle, common pitch circle tangent line. KL is the length of path of contact between the two mating gears. Okay. Let's see what is interference. A little consideration will show that if the radius of addendum circle of pinion is increased to O1 to N. Okay. The O1 to N. The radius of the addendum circle. The radius of the addendum circle is this is the actual addendum. The addendum circle is increased up to O1 to N. Okay, this is the maximum addendum circle. Okay, on to N. The point of contact L will move to L to N. The point of contact L is this is the actual addendum circle. This is the point of contact L. This is moved to N. This point. Okay. When this radius is further increased, this radius is further this O1 to N radius. This R1 is further increased. Okay. The point of contact L will be on inside of the base circle of the wheel. The point of contact, this N point, the point of contact, the base circle, sorry, point of contact the L will be the inside of the point of contact L is the inside of the base circle of the pinion. Okay, sorry, base circle of the point will be moved up to here. Okay, base circle of the gear. Okay, this point of contact. The wheel and not on the involute profile of the teeth on the wheel. Okay, here from this case, the involute profile not touching this gear, this base circle. Okay, the end of the gear only touch this involute profile, not touching this gear. Let's see here. The addendum circle is further increased. The actual addendum circle is the radius of the addendum circle is further increased. Okay, further increase. The what will happen? The involute profile of the two mating gears not touched. Okay, because of the uh, addendum value is more here. Okay, so the end of the gear teeth are pinion. Okay, here the gear teeth is cut to the pinion gear teeth. See, because of the increasing and addendum circle, addendum radius, the end of the teeth is touching to the this pinion Okay, because of this, the undercut. This phenomenon is called a undercut. The undercutting is happened in the pinion gear. Similarly, the as well as gear also. Okay, because of the interference, the undercutting will be happen. The both interference and undercutting, because of this undercutting and interference of the gear, the velocity ratio will be reduced. We cannot achieve the maximum velocity and maximum velocity ratio. In order to avoid this interference and undercutting, we have to follow the some of the techniques that we'll see. Okay. Uh, okay. The tip of the tooth on the pinion will then undercut the tooth on the wheel. Okay. Already I will tell at the root remove the part of the involute profile. Okay. Of tooth on the wheel. This effect is known as interference. This effect is known as interference or undercutting. Undercutting of the gear. Okay. And occurs when the teeth being the cut. Uh, in brief, the phenomena when the tip of the teeth undercuts the root and the mating gears is known as interference. Okay. Similarly to the gear also. Okay, this is the pinion. Similarly to the gear also. So the above discussion, we conclude that the interference may only be avoided if the point of contact between the two teeth is always on the involute profile. So the point of contact between the two mating gears should be the involute profile. The mating point should be the involute profile. The exceed the involute profile, the interference will be occur. Okay, because of this discussion, we conclude the mating point of the two gears. This is the mating point. The involute profile is mating here. Okay, but here the pinion is involute profile, but the gear is the end of the gear is touching in the gear. Okay, so always the contact point should be in the involute profile of the gear and pinion. Okay, always on the involute profile of the both teeth. Okay, uh, in other words, the interference may only to prevent if the additive circle of the two mating gears cut the common tangent to the base circle. Okay, the involute profile may be cut. Okay, atom circle of the two mating gears cut the common tangent base circle between the point of tangency. Okay. Now, when interference is just avoided, the maximum length of path of contact M1 when the maximum atom circle of the pinion wheel passes through the point of tangency N and M respectively as shown in figure. Okay. The maximum length of path of approach, maximum path of approach MP equal to R sin phi. See MP equal to this is MP is the gear. Okay, sorry. MP is the pinion portion. This is the pinion portion. MP is equal to R small r into sin phi. Okay. As well similarly and MP and PN or NP. PN is equal to capital R into sin phi. Okay, point of recess, the point of disengagement. The point of approach is MP into R sin phi, and point of length of maximum length of path of recess is PN into R sin phi. The maximum length of path of contact MP equal to Mn equal to MP plus Pn are the value and simplify small r plus capital R into sin phi. Small r is pitch circle diameter of the pinion and capital R is pitch circle diameter of the gear. Next one is maximum length of arc of contact. Similarly, from the previous tutorial, the arc of contact is nothing but length of path of contact divided by cos phi. The same formula only we are using here. Usually here. So maximum length of arc of contact is equal to path of contact. What is path of contact value? Small r plus capital R into sin phi divided by cos phi. Okay. Sin phi divided by cos phi equal to tan phi. So length of arc of contact equal to r plus small r plus capital R into tan phi. Okay. The next note, in case of addendum on pinion and wheel in such that the path of approach and path of research are half of the maximum possible value. Okay. The addendum value, addendum and pinion, the addendum of the pinion and wheel in such that the path of approach and path of research is the half of the maximum possible value. Means the path of approach Kp equal to Kp plus Pl only, no? Length of path of contact Kp equal to half of the Mp. Okay, that means Kp is square root of Ra squared minus R squared cos squared phi minus R sin phi equal to what is Mp? Mp is equal to R sin phi, small r sin phi. Similarly, path of research Pl equal to half Pl. Okay. Finally, length of path of contact Kp plus Pl equal to half into Mp plus half into Pl. Okay, simplify this equation. Uh, Small r plus capital R into sin phi divided by 2. This is length of path of contact. Using this relation, we will solve the one tutorial problem. Okay, interference of the inverted case. Using this lesson, using this formula, we will solve one problem, tutorial problem. Let's see the problem. Problem number 4. Two mating gears having 20 and 40 inverted teeth of module 10 millimeter and 20-degree pressure angle. The addendum on each wheel is to be made of such a length that the line of contact on each side of the pitch point has half the maximum possible length. You see in note now, the note. This condition only they are given. They are in the question. In case of addendum on the pinion and wheel, such that the path of approach and path of recess are half the maximum possible length. This condition only given in this problem. See, the addendum on the each wheel is to be made of such the length of that the line of contact on the each side of the pitch point have a half the maximum possible length. The addendum value should be calculated from this condition only. In this problem, the addendum value is not given. Okay. Using this lesson only, we have to find the addendum value of the gear and pinion. Okay. Next, determine the addendum height for each gear wheel. Okay. Determine the addendum height for each gear wheel. The next one, length of path of contact, arc of contact and contact ratio. These three things, length of path of contact, arc of contact and contact ratio are the tutorial one problem. We are see the similarly we have to find. The new thing is the addendum of height for each gear and wheel. Each gear wheel you have to find the addendum value. This is the things are new from the previous problems. Okay. What are the given data? Smaller t they are given, number of teeth on the pinion, and capital T number of teeth on the gear, and m is equal to 10 millimeter and phi is equal to 20 degree. Pressure angle is 20 degree. To find addendum height of the each gear wheel, length of path of contact, and third one is arc of contact and contact ratio. Go for the solution. First, addendum height for each gear wheel. For addendum height for each gear wheel, find using this relation. Kp equal to half Mp. This relation. This condition only they are given. Since the addendum on each wheel is to be made of such a length that the line of contact on each side of the pitch point. Okay, the length of path of approach and path of research. Yes, have the maximum possible length. Okay, this condition only you are using. Length of path of contact, say path of approach is equal to half the maximum possible length, as well as length of path of research. Length of path of research is equal to PL equal to half the maximum possible length. Okay, opinion. This is for care. Okay, using this relation, you have to find the value of RA. Okay. For this, first we have to find the capital R and small r values. Okay, that is small r equal to m into small t divided by 2. Using this equation, we find the small r and capital R is equal to m into t divided by 2. Okay. And the next one is capital area and small area. Capital area is the radius of around circle for the larger wheel. Small area is equal to radius of around circle for the uh, smaller gear. Capital area equal to r plus addendum of the gear wheel. That is the formula. Here r we know, but addendum of the gear wheel and the pinion wheel we didn't know. So you have to find using the relation. Okay. Here Kp equal to half Mp. Really, you don't use this formula for finding the uh, addendum. Okay. If the question they are giving this condition only, you have to use this condition. Okay. Otherwise, you have to find the different formula is used to find the another value. That will discuss in future problems. Okay. Next tutorials we'll discuss if the condition they are given this condition above the maximum possible length. The addendum value of the each gear and wheel is equal to of the maximum possible. If they are giving this condition only, you have to use this formula, or otherwise you want to use this formulas. Okay, please aware of this. Uh, and the square root of RA square minus R square cos square phi minus R sin phi equal to R sin phi divided by 2. Okay, here the R value we know and pi value we know and small r value we know and RA value we didn't know. Okay, from this equation you will find the capital RA. Apply all the values and simplify the equations. Okay, simplify the equations and finally we get the RA value. Okay, this is simple mathematics only. Okay, simplify the this equation and we will give the we will find the RA value. Here RA value is equal to 206.5 millimeter. From this you will find the addendum value of the gear. Okay, RA equal to capital R plus addendum of the gear wheel. Okay, so what is addendum value? The addendum height of the larger gear wheel is equal to RA minus capital R. Capital RA minus capital R 206.5 minus 200. Okay, the addendum of the gear wheel is 6.5 millimeter. Similarly, you will find the addendum of the pinion wheel. Okay, PL equal to half into PN. Small RA square minus R square cos square phi minus R into sin phi equal to capital R sin phi divided by 2. Okay, using this relation, you will find the value of small RA. Okay. Similarly, we find the small addendum value of pinion wheel. Okay, here the pinion addendum value is 6.2 millimeter. Okay, simple only. And then next length of path of contact, arc of contact, and contact ratio we'll find. Okay, length of path of contact is equal to Kp plus Pl, or else half into Mp, or else half into Pn. That means r plus r means small r plus capital R into sin pi divided by 2. Using this equation, you will find the length of path of contact. You can add this value or else you can use this value. Okay, both the values should be same. Okay, length of path of contact is equal to 51.33 millimeter. Next, length of arc of contact. Okay, length of arc of contact is equal to length of path of contact divided by length of path of contact divided by cos phi. Length of path of contact is 51.3 divided by cos 20 degree, and we will get the value of length of arc of contact. Next one is contact ratio. Contact ratio is length of path of contact divided by pitch circle or circular pitch. Here circular pitch is 5 into m. M is nothing but a model. We are using the model value. We will find the circular pitch and apply both the values into this formula and we'll get the contact ratio. Contact ratio is equal to 1.74. Say two gears are mating. Okay, messy. Okay, uh, this is simple problem only. If they are asking Okay, this is very important problem. Uh, Repeatedly in university question, in university, repeatedly asking the same question. Okay, this is very important question. The question they are asking this condition only we are using to find the addendum with this formulas, or else the another formulas are there. Using that formula only you have to find the addendum value. Okay. Okay. Thank you, student. I hope you understand this problem and interference of the inward gear profile. What is interference? What is undercut? How to avoid the interference? Okay. And this problem. Okay. I hope you understand. If you have any doubt, just comment in comment box. I will give you the reply. Thank you so much, and all the best. Thank you.